Hi everyone, welcome back for part 2 of this week's session on using mixed models for designs in which we have repeated measures independent variables. So we finished off the first part by considering a design or analysis options for a design in which the researcher has two repeated measures independent variables. The researcher was interested in the impact of alcohol consumption on performance in hand-eye coordination tasks. But they were also interested in whether the effect of alcohol on task performance was moderated by or depended upon a second independent variable, the difficulty of the task. So they had a two-way design, a 2x2 fully repeated measures design, and we ran a mixed model to test that. We reviewed the output. We saw that there were two significant main effects of alcohol and of task difficulty, and that the interaction between them was also significant. So that provides some support for the idea that the effect of alcohol on task performance is moderated by or depends on task difficulty. So it's consistent with the hypothesis in that sense that there would be an interaction between those two independent variables, but it doesn't directly address the more specific prediction that alcohol would affect task performance only for difficult tasks. That prediction is a little bit more specific about the precise pattern of the effect. So that in turn requires further analysis. It requires analysis of the effect of alcohol broken down at different levels of task difficulty. And that, just as we saw in the between participants analysis of variance session, we can do that for an interaction by conducting simple main effects analysis, which tests the effect of one independent variable, alcohol consumption in this case, at different specific levels of a second independent variable, task difficulty in this case. So let's have a look at that. Let's go back to the analysis that we ran, which was this one. Okay, so we have alcohol consumption and task difficulty. Okay. There's the output that we saw. Now what we need to do is ask for an additional step, just as we did in two-way designs for between participants analysis of variance. So we're going to go to simple effects, and we're going to ask in turn now for the simple main effects of alcohol broken down at different levels of task difficulty. So task is specified as the moderator. And just to help us visualize the pattern, I'm also going to ask for the plot of that interaction. So I'm going to ask for a plot of alcohol consumption on the horizontal axis with separate lines for each level of task difficulty. Okay. So now in the output we have some additional things. We have the tables for the simple main effects, and we have a plot of the effect. Now that's kind of truncated on this axis. So I'm just going to go to more options and increase the range of that on the y-axis from 0 up to, let's say, 20. Okay, we get a slightly better visualization of the effect now. Okay, so what can we glean from that output? Well, first of all, let's consider the simple main effects analyses themselves. The simple main effect of alcohol was not significant in the easy task condition, not significant at all, but it was significant in the hard task condition. Okay, consistent with the hypothesis. Now, just to make sure that it's in the direction we expected, and not the other way around, for instance, we need to look at the means, and we can do so either looking at the means from the estimated marginal means table, or look at the plot. Okay, so this is the plot, and we can see here that the effect of alcohol condition versus control, for easy tasks, this blue line is almost completely flat, no effect whatsoever. But the slope is significant, or the effect of alcohol versus control is significant for hard tasks. And it does indeed look like alcohol consumption impaired task performance more versus control for the hard tasks. So let's consider now another slightly different design, and specifically a mixed design in which we have a combination of repeated measures and between participants independent variables. So let's go back to that research question that we looked at in the first session. Does students' alcohol consumption change over the course of a term? So the researcher initially hypothesized that alcohol consumption would be lower or get lower over the course of a term compared to early on and midway through. But now they're adding a little bit of nuance to that hypothesis. They're introducing a second independent variable, which is whether the student is a member of a sports club or not. So they're hypothesizing here that the effect of time, okay, the pattern of alcohol consumption over the course of a term, will be different for members of sports clubs versus non-members of sports clubs. And specifically, that we would see that predicted pattern for people who aren't members of sports clubs, but we wouldn't see it for members of sports clubs. Perhaps their level of alcohol consumption is lower to start with and stays a little bit more consistent because of regular socials, for example. So what we're saying here is that the effect of the first independent variable, time, in this case over the 3 time points in term, will depend on or vary as a function of the second independent variable, whether students are a member of a sports club or not. So it's an interaction effect. Okay. Now the key thing here is that it's a mixed design where the first independent variable is repeated measures, just as we saw in the first part of the session, but the second independent variable, sports club membership, is between participants. People either are or are not a member of a sports club. So again, it's helpful to map that out schematically. So here we have the repeated measures factor, the effect over time on alcohol consumption, broken down now by whether students are sports club members or not. So here's that pattern that we saw and predicted in the first part of the session, but now we're seeing that it's only being specifically predicted for non-sports club members. Okay, high at the start of term and then really tapering off as term progresses. Whereas for sports club members, the prediction is that it's going to be a bit flatter across the course of the term. It starts lower but maintains at the same sort of level. Okay. So our analysis options here for this mixed design, in which we have at least one repeated measures but also a between participants independent variable, is a two-way mixed model. Again, that tests the main effects of the two independent variables and the interaction between them. So let's look at that. Okay, so here we have our data set now, where we have our 3 levels of time. Okay, alcohol consumption, time is a factor. Participant once more is our identifier. The participant identifier, sorry, is our cluster variable. And finally, sports club membership is entered as a second factor, a second independent variable. So to run the analysis once more, we have to specify that we want the random intercept for participant identifier. Now, because we're predicting an interaction, I'm also going to ask for the simple effects of time, this time broken down by the moderator, which is sports club membership. I'm also going to ask for the estimated marginal means for all possible combinations of those independent variables, and I'm going to ask for a plot of the effect. So I want a plot which shows time on the horizontal axis, times 1 to 3, but this time broken down with separate lines for sports club membership. Okay. So one thing to emphasize here is that, if we recall, time as a variable here has not 2 levels but 3 levels. So as I emphasized in the first part, as well as our overall sort of table here of effects, the omnibus table, we also get the possibility with variables that have 3 or more levels of breaking it down to look at specific contrasts between individual pairs or combinations of conditions just as we saw for between participants ANOVA. Once more, the default is for factors to be coded using simple coding. So here for time, we also get a breakdown of the contrast between time 1 and time 2, which is significant. The comparison of time 1 and time 3, which is significant as well. But it's also possible to change those. We can look at the polynomial trend for time. We can look at difference coding or Helmert coding, as we saw in the between participants analysis of variance session, if you want to look at different combinations of conditions. Now, because this is a two-way design, we also get tests of whether these simple contrasts, for example here, the difference between time 1 and time 2, in turn is moderated by or interacts with the second independent variable, sports club membership. So this effect here is the test of whether the time 1, time 2 contrast in turn differs as a function of sports club membership. In this case, it's non-significant, so it doesn't. And likewise for the comparison between time 1 and time 3. So it is possible to delve further down into more sort of fine-grained contrasts when you have independent variables with 3 or more levels. But I won't go into that in much depth for this analysis. So let's go back to the slides and pick out some key bits of the output. So here's the main table, which shows we have, again, significant main effects, both of time and of sports club membership. But the interaction between them is not significant. Okay. Let's look, nevertheless, at the simple effects of time over the course of the term, broken down by sports club membership. And we can see that it's highly significant for both sports club members and non-sports club members. I say conditions here, it's probably better to refer to it as levels, sports club member or non-sports club member. Here's the figure, which just again emphasizes that pattern. So we can see here that two separate lines for sports club members and non-sports club members. We can see that maybe time 2 and time 3 there's some differences between sports club members and non-sports club members, particularly at time 2, but actually the interaction was non-significant, and that's reflected in the fact that the lines are largely sort of parallel. The slopes are very similar looking. Okay, so overall that decline in alcohol consumption over the course of the term seems to hold for both sports club members and non-sports club members, contrary to the prediction. So to close off now, I'm going to do something similar to what I did in the between participants analysis of variance session and consider a design that has more than 2 independent variables. So let's go back to that research question looking at the effect of alcohol consumption on performance in hand-eye coordination tasks. So we had that hypothesis that alcohol consumption would reduce performance, but only for difficult tasks and not for easy tasks. But now we're adding a second moderator, a third independent variable. The researchers now are suggesting that that's going to be especially so amongst people who do not play sports involving hand-eye coordination. Perhaps the reasoning being that people who are more trained in doing sports with hand-eye coordination will be more resilient or robust to things that might otherwise undermine their performance. They're better trained, better able to cope with circumstances like having had a drink of alcohol that might otherwise reduce their performance. So they'll be more robust to the effect of alcohol. So here, this might translate into a design that has 3 independent variables. We've got alcohol consumption, fully repeated measures, task difficulty, again, fully repeated measures, as we saw earlier, and now a third factor, whether they are a sports person or not, and that's between participants. So what we have here is a 3-way mixed design, so a combination of repeated measures and between participants factors, and that's allowing us to test that prediction, stressed as a model or translated into a model, that the effect of the first independent variable, alcohol, is going to depend on the second independent variable, task difficulty, but now in turn we're saying that's only going to happen at specific levels of the third independent variable, sports, whether they're a sports person or not. So we are suggesting that there will be a three-way interaction between the factors. Again, schematically, we have, it's useful to break it down in this way. So here we have the alcohol by task difficulty effect. And we're saying that the effect that we saw in the previous run of this analysis here is now actually only really going to be evident amongst people who don't play sports involving hand-eye coordination. So not much effective alcohol for easy tasks, but an effective alcohol for hard tasks. And we won't see that to the same extent for people who do play sports involving lots of hand-eye coordination. So our analysis options here, three-way design, mixed design, so a three-way mixed model. And again, just as with a three-way between participants analysis of variance, the three-way design will give you 7 effects. The 3 main effects of the 3 independent variables, the 3 possible two-way interactions between combinations of those variables, and finally, the 3-way interaction between all 3 of the independent variables. So let's go and run that. We have our, oh, not this example, it is this one here. Okay. So again, we're going to run a mixed model. Once more, we have participant as our cluster variable. We've got their score on the hand-eye coordination task. We've got alcohol as the main factor, the sort of the focal independent variable. And once more, we have task difficulty as a second independent variable. Now we have a third independent variable, which we're going to add, whether they are a sports person or not. Let's allow the analysis to run. We specify participant identifier as the cluster variable with random intercepts. I'm going to ask for, first of all, the simple main effects of alcohol, but this time not just broken down by task difficulty, but also by the second moderator, the third independent variable, sports club, sorry, not sports club membership, whether they participate in sports or not. Estimated marginal means, I'm going to ask for the means broken down by all possible combinations of the independent variables. And finally, I will ask for a plot. So I'm going to plot alcohol as the main independent variable on the horizontal axis, separate lines once again for task difficulty, but now separate plots also, so we're breaking down this in turn with separate plots depending on whether they participate in sports or not. Okay. So here's the main table of effects, all 7 of them. There's the simple effects, and finally, after the means, we have the plots. So I'm just going to extend the y-axis once again to fuller range from 0 to 20. Gives a better illustration of the effect. And that will give us an indication of visually, descriptively, of whether the pattern, that two-way interaction, differs as a function of whether they played sports or not. Okay. So what can we take from that analysis? Let's look at the main table first. So we've got significant main effects, just as we saw in the previous run of this analysis, where we only looked at alcohol consumption and task difficulty. The main effects of those two variables are significant, as is the interaction between them. Once again, it looks like alcohol, the effect of alcohol on task performance differs depending on task difficulty. But now we have a non-significant three-way interaction, which is suggesting that this two-way interaction, what we saw before, the interaction between alcohol and task difficulty, does not in turn differ as a function of whether the participant plays sports or not. So let's look at the simple main effects analysis. So while, it does actually look like the simple main effect of alcohol is only significant in the hard task condition for people who don't play sports, the fact that the three-way interaction is not significant suggests that the pattern actually is not different. The pattern of the two-way interaction between alcohol and task difficulty does not differ between sports people and non-sports people. Okay, so we shouldn't conclude that this slope is necessarily different from this slope. What can we conclude from the analysis? Well, firstly, alcohol consumption does seem to reduce performance on the hand-eye coordination tasks, but that only seems to be true for difficult tasks and not for easy tasks. So we saw that through the two-way interaction between that and the simple slopes analysis and the descriptive statistics that confirm the pattern. This in turn does not depend on whether participants played sports or not. So the three-way interaction was not significant, which runs counter to that extended prediction, that extended hypothesis that we tested. And although we saw that the simple main effect of alcohol was indeed significant only for hard tasks amongst non-sports participants, the effect was not actually significantly different from the effect in other conditions. And that's the three-way interaction. Okay, the fact that that is non-significant should mean that we shouldn't interpret those slopes as different from one another. Okay. That's it for this week on mixed models for repeated measures designs, or designs that involve at least some repeated measures independent variables. Next time round, we're going to turn our attention to analysis options for designs that have continuous independent variables or predictors. And through that, we'll be reintroducing regression. All right, thanks very much. See you then.